So the LIGO detector that the Americans have, the LIGO detector that the Europeans have now, is able to give us a triangulation of the location of these monster black holes. And what happens when two black holes collide? Well, they form a bigger black hole. That's right. They don't scatter. They don't break apart. They simply reform because of the enormous gravity and create an even bigger black hole. Now, what's the next step beyond this gigantic LIGO detector on the planet Earth? Eventually, we want to put them into outer space. Why? Because in outer space, you can build a detector that's not just a few miles across. You can build a detector that is 1,000,000 miles across, creating the biggest sensor ever created in the history of the human race to detect radiation not just from colliding black holes. No, we want to go beyond that. We want to detect radiation from the instant of the Big Bang, the instant of creation itself. This means that sometime in the future, we may have baby pictures of the infant universe being born. Wouldn't that be great? I work in something called string theory, and we hope that not only will we detect the baby pictures of the instant of creation, but we'll also see evidence of an umbilical cord connecting our infant universe perhaps to a parent universe. This is the multiverse idea, the idea that the Big Bang was perhaps caused by the collision not of two black holes, but the collision of two universes, or perhaps the splitting of a universe into two smaller universes. Now, remember that every time a new kind of telescope came into being, it revolutionized our understanding of who we are in this universe. For example, look at Galileo. About 400 years ago, Galileo turned the telescope to the heavens and opened up what we call astronomy. All the myths and fairy tales of the universe could be dispensed with your own eye. With your own eye, you could see that many of the teachings of the church were, in fact, wrong. The second revolution came when we replaced light telescopes, like with Galileo, with radio telescopes during World War II. Radio telescopes were perfected by the Allies as a forerunner to radar. But instead of detecting ordinary airplanes in the sky, these radio telescopes detected galaxies out there, colliding galaxies, quasars, infant galaxies. A whole new realm of telescope technology opened up with radio telescopes. Now we're talking about the third great revolution, and that is detecting not light waves, detecting not radio waves, but detecting gravity waves. And this, in turn, can open up a whole new realm of astronomy. In other words, light telescopes opened up the world of comets, meteors, and planets. Radio telescopes opened up the world of galaxies. With gigantic gravity wave detectors, we're now focusing in on black holes and the creation of the universe itself. This is amazing. Now, if you go to nasa.gov, you can see pictures of the Big Bang about 300,000 years after the instant of creation. You see a fireball. However, it's frustrating because you're seeing a picture taken roughly 300,000 years after the instant of creation. You're looking at the afterglow, the aftershock, the echo of creation. What we want is a baby picture of the infant universe as it emerges from the womb. We want to get detailed photographs of the instant of creation, not 300,000 years after creation. No, we want to get it to within a trillionth of a second of the instant of creation. And that's the promise of gravity wave detectors in outer space. The detector is called LISA, Laser Interferometry Space Antenna. It consists of 3 satellites that orbit each other. And in outer space, these 3 detectors shoot laser beams at each other. So think of a triangle whose sides are made of laser beams, And the three vertices are the three satellites. If a gravity wave from a distant black hole or the Big Bang hits this triangle, it'll cause the laser beams to vibrate. And that's the way we're going to detect gravity waves from outer space and gravity waves from the creation of the universe itself. So hold on to your hats, because what we are witnessing is the birth of a new technology, a new kind of telescope. Not a light telescope of Galileo, not a radio telescope, but a gravity wave telescope that could peer into the heart of a black hole and into the instant of creation itself.